Thank you. Let's push through. Okay. So today we're doing the inverse trig functions. There are 3 of them, which is cosecant, secant, and tangent, or cotangent. Thank you. Thank you. So we're going to do those 3, which is the inverse of sine, cosine, tangent, of course. If we get time, I'll teach you how to do some on the calculator. Some you won't be able to, especially when they say find the exact answer. Whenever they say the exact answer, they're asking you to do it by hand, pretty much. Okay? And then we'll find the exact values of the composite functions with inverses. Okay? Can I change the slide?
Yes.
All right. Like I said, this is going to be a lot of notes here. This.
Tell us what to write.
Yeah, that's what I was going to tell you here. Like, what matters here. I don't want to talk over you guys. Not feeling it today. This notation right here. That is not f to the negative 1. Well, technically kind of is. Because it does an inverse, right? To make it a positive, you have to flip the function. But that's referred to as the inverse function. So whenever you see f to the negative 1, you're asking for the inverse function. So there's that. Please remember that in order for it to be an inverse, it has to be able to reflect across the line y equals x. Good. Yeah, write those 2 things down. I love how Italians never waste anything, right? Oh, that bread is really hard. Slice it up. Call it something cool. Biscotti.
When my brother was first here, they're and we used to go through like those big things of discovery. We go through like 2 weeks of those too.
Wow, especially with some coffee. Can I change the slide?
Yeah.
All right, cool. Thank you. If you take a look at the sine function, and we do the horizontal line test, you'll see that it's really not a one-to-one function, right? So it's a function, but it's not a one-to-one function. You guys know what that means? Okay. So we know that functions pass the vertical line test, correct? There's another, so that means that for every x, there's 1 y.
But there can be, for every y, there's going to be more than 1.
Right. So I used to tell a little story. I don't know if you guys ever had me. I know Sunday Low did. Yeah, the whole boy-girl thing, right?
That's what the regular functions are.
Good. So a regular function, the rule says every x has 1 y. Okay? That's it. That's the only rule that needs to apply. So, but in order to be a one-to-one function, it's got to be a monogamous relationship. 1 boy to 1 girl, or 1 x to 1 y, but also 1 y to every x. So and that's why we use the horizontal line test. If we take a look at 1/2 here, the girl labeled 1/2, or whatever you want to call it, would have multiple people over and over and over, right? Therefore, failing that horizontal line test. Most functions that fail the horizontal line test, you have to limit their domain in order to be able to find the inverse function. Okay? And that's what we're going to have to do with our function here. Which, that was bad. So, what we're going to do is we're going to restrict the domain on the sine function on this interval from negative 1/2 to 1/2. So this is what we'll look at, this piece right here. Okay? We're going to restrict it right in there. Cool? Because right there, that piece alone, that red piece, is a one-to-one, isn't it?
Wait, is this 4.7?
So that's it.
No, this is 4.7.
Oh, this is 4.8.
What?
Bruh.
Oh no, this is 4.8.
8.
No, 4.7, because it only goes to 4.8. The other one's tomorrow. Yes. What's up?
So for this,
Go ahead.
it can't repeat once, right? Or can it repeat?
In order to be a one-to-one, every x has to have 1 y, but every y can only be with 1 x as well.
Okay, so this is
So the point here being that the sine function, because it is sinusoidal, every y would repeat over and over and over, correct? It would fail that horizontal line test.
Yeah.
So what we have to do to find its inverse, and I'm throwing air quotes out there, is we would limit its domain. We're say, okay, an inverse exists only if we look at this piece from negative pi to pi, sorry, from negative pi halves to pi halves. So if you take a look at this, that piece has an inverse. The rest of it, not so much, right?
Why that?
Because at this piece, every x has one y and every y has one x only. If I were to go any further, this y's would repeat themselves, wouldn't they?
Yeah.
Once I've hit that apex and I start my way down, all the y's would start repeating themselves. Does that make sense? So we're going to limit from here to there when we look at the inverse sine function, okay? And here's what you need to know. The inverse sine function. We are going to limit it from negative 1/2 to 1/2. What else do we have here? That means that its domain is going to be from, its range would be from negative pi half to pi half, because remember they flip positions whenever we do those?
So is that the same with all inverse sine functions?
Yes. Well, it happens with any function. Remember that when we find its inverse, all of the x values become the y values now, and all the y values become the x values.
No, I meant like the domain.
Well, in the domain, what's the range of sine? If you want the domain of the inverse sine, think about the original. Sorry, I have to write it down sometimes. So if I think about the original sine domain, we restricted it, correct? From negative pi halves to pi halves. So that's my domain. My range. What's the range on sine? Negative 1 to 1, right? So when I look at sine inverse, they're going to swap. Domain will become negative 1 to 1, and then range would become negative pi halves to pi halves. Nothing has changed. It's the same whole inverse function thing that we should do.
But like, will you restrict it to negative pi halves to pi halves every time?
Yes. Yes. Because if we do it any other piece, you would have repeating values, wouldn't you? So if you go back and think about this, maybe I restricted, maybe I didn't want to do that and I wanted to be lazy and I just wanted to go from 0 to pi. Well, see here, y duplicates, doesn't it? And I can't have that. So any other piece in there that you would kind of pick from the, it wouldn't work so well. So that's why we always go from negative half to 1/2. And then we should be good there. Okay? Alright, cool beans. I can go back. Sorry. Yeah, good idea. It's importante.
Are you recording?
I believe so, yeah.
Oh, doesn't it say watch these? Ah,
I watched them.
Do you? Good.
I subscribe.
I should monetize, right? I'm gonna monetize, put commercials every like 10 seconds.
Oh no. You get paid 3 cents.
Oh,
And
man.
like 20 bucks a view.
I won't do that because that drives me crazy. Like, right when it's good, it's like, Arby's. We have the meats. No, they don't. I get mad at Arby's. I went over there one time, like, I really wanted one of those beef and cheddars. And I opened it up, it's like a sandwich, and it looks like they spread the cheese like they spread mayo. Like, where's the cheese, man? You look at the commercial, all dripping everywhere. Like, where's the beef? But they do look amazing on the commercials. Like,
It's all juicy, you know, they're like,
I heard you can order, what's it called? I think it's called a mountain. It's like $10 sandwich, but they put all the meats, like everything in there. Gotta look for it. I'm gonna try that out. $10 is worth it, right? For some heartburn. Yeah, it's good? Okay, so here are the two side by side. Here's the original sine function on the left. There is what piece that we restricted the domain to. And if you take a look at the inverse function, you can obviously see that the domain and range have swapped, and the shape, it looks a little different. It almost looks like our, kind of look like our tangent, doesn't it?
Yes.
oh, now I see it. I was like, what is wrong with it?
Flip left to right. No, that's not what I wanted to do. Yes, I do. Yes, I do. I need to flip one more time, don't I? Flip up and down. I missed it.
Real.
Flip. Is it left or right?
Yeah. And then just like turn it upside, turn it around.
And then,
Like move it into like a
there you go. That's what I needed to do. Should match.
close enough.
Close enough. Here. Right there.
Wow.
That's not cute.
And no, it's not two. It did not turn into two parabola-looking things. It starts here and ends up here. See the blue, and then there's the red. I know. When I first saw the picture, I was like,
If you need a wing, the butterfly.
okay. And you see that they do mirror each other, don't they? So
Across the x, y.
y equals x equation, because there's no y equals x axis. All right, cool there.
Yeah.
Moving on. You might want to write these down or take a picture. Because we are restricting the domain from negative pi to pi halves, here's what the sign values will be. Over at negative pi halves, it should be -1, blah, 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 all the way through. Peanut.
Peanut butter.
Jelly.
Bring it back on my.
Go ahead.
Peanut butter and jelly.
Theta is the angle, and then it's what the value of that would be at that point. Okay? And these are for the inverses. You want to try to make some sense out of it? Yes, please. Okay, so that's not what I want. Oh, page width. Bro, I've been slacking all day. Okay. I'm not. All right, so
One day.
negative pi halves. Negative pi halves would be
Yeah, we're okay.
down here, wouldn't it? Right?
Yeah.
What's the coordinate here?
Something.
-1, 0. And we're looking for the sign value, which is the y. There you go. -1. Let's see here. If theta is, let's do pi fourths. Negative pi fourths is here, correct? Which is technically a -45 degree. We should have -1, -1, radical, not -1 there. Just kidding. Should be a 1. Okay. So what is the sign of that bad boy? -1 over radical 2, which becomes -radical 2 over 2. So there's that one. So there's no mystery to them. I mean, you've been doing them, right?
Why does it say sine of 0 equals x?
Sine of 0? Where?
Theta, sorry.
What is it? What?
Sine of theta equals x. Number 3.
Yeah.
Like that.
That?
Yeah.
Yeah, but you're looking within this interval. That satisfies that. So it's what you've been doing. It would still be the same idea. That's distracting. Okay. Okay.
Well,
If-
like, okay, never mind. I take that back. I understand how theta relates to the sine of theta, but why does it say sine of theta equals x?
It's just
Like, I don't make that connection.
No, don't think of x as the actual x value. Think about it as something that we don't know. In this case.
Oh, okay.
And that's why, yeah, I understand your confusion there. Because you're used to making x cosine. Right, it's not. It's not in this case. In this case, it's something. It's an unknown. Okay? Good question, by the way. All right, cool. So, here's an example. Hey, sine inverse pi thirds, or radical 3 over 2, right? Where's radical 3, 2? When they're both positives, it's going to be over here. Okay? So, what?
36.
It's a 30, 60, 90? Which one's which?
The 30.
Which one is it? It's the 60, right?
yeah, that's just
It's got to be radical 3, 2, 1.
Yeah.
But what angle is that then?
What?
What angle is it? What angle gives me that?
Oh.
The second.
No, it's a sine.
Yeah.
We have it done. What angle is it? It's right there, right? It's 60. But give it to me in radians.
Pi.
Yeah.
Is it pi thirds?
Yeah.
Okay.
Basically, we've been doing
Let's
this
check
whole
it.
time already.
Where's negative? What was it?
-0, 2.
No, it was
Negative pi.
it was
That's
Yeah.
what it is.
positive pi thirds. So positive pi thirds. Oh, look, there it is, pi thirds. Did I write by thirds? I feel like I didn't. Yes, I did.
Yeah.
Yeah, you did. So we've been doing it like this whole time already?
Okay. All right. I'm sensing a little confusion here. I'm going to hopefully alleviate some of that. Thanks. If I wrote sine 30, what is sine 30 a call for? What is it asking me to find? It's asking for something specific. What is it?
The y of
It's asking for a ratio of a triangle, right? Because doesn't this equal some ratio? What ratio would in this case? It's the ratio of the opposite over the hypotenuse.
Yeah.
So I'm just asking for some number, which is 1/2. Correct? What if I said, hey, you know what? I know that sine theta is 1/2. What is theta?
30.
You could do that, right? Well, that's not how we ask the question. We say this. We'll ask like this instead of like that. Okay? So when you do an inverse problem, it's not a call for the ratio, because I know the ratio. I want to know what angle it belongs to.
Oh,
Okay?
okay.
Does that help a little bit?
So we're just gonna be finding because of it.
A lot of, yeah, most of it.
Oh, that's okay.
But we'll what?
Hey, brother.
We did it. It's 30. Well, pi 6?
Yeah.
Pi 6. In radians. In radians. In degrees it would be 30. They'll do sine inverse. Yeah, they'll sine inverse something. And you have the chart with all the answers already.
So what?
Okay? You couldn't, yeah. Just figure out what meets those conditions. But make sure that you're careful too. Where'd it go? Make sure that you're in the correct interval, okay? So in this case, they're just gonna ask for these bad boys. So let's see here. Did we do that one already? Yeah, we did. That's why the writing is there. Okay, so think about this one. I mean, you already kind of know, don't you?
Oh, that's good.
Do it by hand first before you look at the chart, because the chart has them all. It's radical 2/2, so I know it's a 45-degree angle,
Yeah.
right?
Yeah.
But it's negative though.
So it's gonna be opposite.
So what
it's gonna be negative 5 fourths. No, 5 fourths.
Oh, is it my first?
Positive 5 fourths.
Is it
Alright, like
1,
1,
2, 3,
3 divided
4, 5, 5 pi? Or is it negative 1 pi?
What?
I mean negative 4 pi fourths.
It'd be negative 5
Negative
fourths.
5.
Which one is it?
5 fourths.
Negative pi fourths. Right?
Stop.
Why is it not the other one?
5
Because it's, it only goes down one time.
Oh, because it's inverse,
It
you're
doesn't
not like that, right? Get it now.
Got it.
Okay. Yeah, if you think about your, here it is. You only go from negative pi to, or sorry, negative pi halves to pi halves. So the other one's not even in its domain. Okay. Questions, anybody?
Oh, wait.
Don't just look at me with a glazed look.
So is what I said right, that you're integral, since it's inverse, you're going that way?
Right. If you look at if you think about the inverse one, what is this? Negative 1. It is how negative 1 to 1,
Yeah.
and then I go up to negative pi halves,
Yeah.
and then I go down to. Sorry, that's not negative there. It's stupid. Negative pi halves. So it should look something like this, and then negative. What would that put me at? Does that work? Yeah. So it would be at negative quarters, right? Because that value would have to be here somewhere, right?
Yeah.
So it has to be the negative version of the angle, so negative pi fourths. and I can't go further than that, so it wouldn't be okay. And if I went over here, I wouldn't satisfy that value. Is that what you were saying?
That makes sense.
Okay.
Not even worry.
We're good then?
Yeah, we're good.
Over here? Genoveva, you have a question.
Is there a way you can solve this
Guys, no.
Is there a way you can solve this by
Yeah. Okay, I need a sign. It's going to be negative, so negative radical 2. Actually, it shouldn't go that way. Well, actually, it would be, huh?
Yeah.
It would be negative radical 2, and then you have a 2 here. And you'd want to figure out what that is. Well, I don't know if you can see it, but it's obviously a 45, 45, 90, because you got two sides of the same hypotenuse. So 45, negative 45 degrees converted into a radian. Negative 5/4. Okay? And that shouldn't be negative, it's still positive, sorry. But you get it. The two sides are the same, they're isosceles. Or you can look at this graph, make sure that you're in the domain as well, and all that good stuff. Okay? All right. Any other questions? Gallus? Good? Okie dokie, artichoke. Okay, here's cosine. Now cosine we can't do that bit either.
So would it be on the other side?
This one doesn't cross the 0. We're going to take the piece from 0 to pi. For cosine, we take the piece from 0 to pi. Okay? And obviously you can see that that one would have a reciprocal there. You okay there? You guys still need a slide for anything?
Yes.
Yes. That light is distracting. Where's Denise to enjoy it? There she is.
All the clouds look like breathing music videos.
Did you guys hear about Ariana's tattoo? It's hilarious.
Barbecue, Japanese barbecue fingers on her. Dang, that's rough.
She meant to get the whole phrase, but it hurt. So she stopped.
I thought she was trying to get what's the name of her song? 7 something?
Yeah, she was supposed to get 7 rings.
Yeah.
But
Instead it just said
she put the symbol in the wrong place. And
She didn't. Somebody did. Of
uh,
course she didn't do it. Why would she do it?
no, she chose to do it because she has a Japanese tutor, and so whenever
No!
so she told
What if
the
you let-
guy to do it that way, but she read the wrong text or something.
What if you rotated her? It's like, oh, did you have Japanese barbecue on you?
That sucks, teeny bopper. Ready? Okay, here's more of the same stuff we were talking about a minute ago. The inverse cosine from 0 to pi, ranges. Sorry, that's not right. That should be
That's your range.
that's our new range.
Yeah, because it flips, remember?
Yes, range, that's our domain. I think the next slide's probably better. Yeah, this one does it better. Here you go. So write these numbers down. On the inverse cosine, domain is from -1 to 1 again, but our range goes from 0 to pi. 0 to pi. 0 to pi.
The one on the left is the regular cosine.
The one on the left is cosine normal cosine. The one on the right is inverse cosine. I can't left, so we're even.
Wait, what is it called when you can use both hands? You can
Ambidextrous.
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 I can't say that.
I had a friend that couldn't say quarter.
What?
Fans can't say soldier. Okay, you don't know who that is, but one of my friends can't say soldiers.
Shoulders?
Oh yeah, Grace is little sister.
Grace Owen?
Yeah, her little sister. You can't say like half the words.
Aww. English is hard.
Math is hard.
No, math is universal. There's only one. We all speak the same language no matter where you go.
So there's like proper English and then there's like English English.
I don't even know proper Spanish.
Yeah.
Do you know
No
how
one
to
knows
speak
proper
ASL?
Spanish.
Do you know how to sign?
A little bit. No, is it? No, I don't forget.
Wait,
I took it. I was pretty good at it, but who do I talk to? And then I just forgot about
I
it.
know.
I remember.
I started teaching myself because I have cousins, like 6 cousins that are deaf.
You want to know the coolest thing though? One time when I was taking the class, I actually had a deaf person come through the drive-through.
Oh yeah, I had a deaf person coming through Panda, and I was like so happy. I was like, well, not happy. Like,
No, but I'm thinking like, why?
Like I was just like,
You
glad
can't
I was able to.
drive-through, right? So he just asked for the little menus because we used to have like, and they go, okay. He gave me his email. It was strange grammar. I don't know if you know about sign language, but their grammar is very different.
Yeah, very.
Oh yeah.
So like, instead of saying the ball is the big ball, they'll say ball big.
Yeah, well,
They change everything around.
Well, they have to. It's not hard to big.
I learned that from my book.
All right, here's your cosine stuff. Here's your cosine values. You should still recognize them. Recognize them.
This is for the exact value.
Cosine 0 is still just 1. Pi 6 is still just radical 3 over 2. Those should not be. What'd you say about my mom?
That's funny. Ooh, pirate sounds so good. Ernie.
Pirates, fish and chips.
that's
Yes.
good.
They used to have the seafood platter, and that was my favorite.
Oh my god.
But now it's like
I'm
it's not that great anymore.
The one in okay, I was the one in Chandler, and literally, it was like so much better.
Yeah,
I don't know why, but like the fries were just
I believe it. I believe it. Totally believe it.
I look at my side.
We used to drive from Eloy to Casa Grande to get the seafood platter. I used to love it.
That's
That's
not
like
that far.
everybody right now. They're about to drive
Not when you use on a budget.
Florence
I don't care if I don't eat for a whole month. I'll eat a shrimp every day.
yes.
food.
I'll be good.
The crispy shrimp.
Ooh.
I love how we always talk about food.
Yeah, but you know what annoys me? Because I think we're hungry. Like next period is already just lunch, and half the people are eating right now. You know what annoys me though? Some of those all-you-can-eat places,
Yeah.
like not all you can, not buffets, but like you go, for example, Red Robin. They go bottomless fries, right?
Yeah.
But every time you order fries, you ever see that like the amount is just less and less and less every time,
Yeah.
and they take longer and longer to get there.
Yes.
They do that on purpose.
Have you ever been to our Boston place? We
No.
ordered like, I think it was 30 boneless wings. They counted this little thing as a boneless wing.
I would have said
was
something.
Like, no, we
Or how we say in Espanol, boneles.
Wait, say it again.
Boneles. It's the same word, but we just read it in Spanish. I was weak when I first heard it. My wife made me laugh. She's like, "Man, you quieres unos boneles?" I'm like, "What? What is that?" Unas alitas boneles. I wonder what kind of spices that has. She was like, "It was just boneless wings."
That's funny.
It is hilarious. Alitas boneles.
I'm gonna get my grandma to tell me that.
All right, what is cosine negative 1/2?
Negative 1/2 is 6.
What is it?
I don't know. I'm just.
2 pi over 3.
You're not wrong.
I'm not.
No. What is it?
That's just my math. Pi 6. I don't know.
Negative pi
Negative pi 6.
6.
There we
Negative
go.
pi
I'm
6.
I'm
Oh, is it negative pi 6?
No.
No.
2 pi thirds.
It is a pi 6 though.
It's 2
It's
pi
it's an interval of pi 6 though. So you're correct. So what is it?
2 pi
So,
thirds.
hold on, we want to, because we're visual, aren't we?
No.
No, never mind then. It's gonna have to be here. It has to be here.
I am.
Because cosine does not exist here. Genoveva, this is you. So it goes from 0 to pi, right? So our cosine, inverse cosine won't exist here. So angle has to be there. That means we got a 30-degree angle. So it would be 5 pi sixths. Is that what it was, guys? No?
It was 2 pi thirds.
2 pi thirds.
Yeah.
Opposite, that should be a 30, correct?
Yeah.
It should be there.
That's 2 6.
No. We should have
It says on the chart.
1, 2, 3, 4, 5. What am I missing? negative 1/2 2 pi thirds. Oh, we're going backwards?
Yeah.
That's why. Okay, my bad. Hold on. Negative pi halves. It's 2 pi thirds. 30, 30, 30. Okay. Alrighty. Alright, let's move on to the other one then. Last one!
Yay!
The
So they're not all 1 to 1.
No, no, no.
None of them are 1 to 1.
no, none of them are 1 to 1.
So none of them.
So they all have to be restricted.
So no Y.
Okay, I can never mind. Notice that the tangent also repeats itself over and over and over.
Yes.
So we're going to close your laptop. So we're going to restrict it to be from that just one of those intervals.
One period.
Yeah, one period of it. And that goes from negative pi to pi.
You mean negative pi halves to negative pi halves?
Thank you. Negative pi halves to pi halves. Same information.
She said,
Hold on.
You're welcome. I think. I don't know. I missed something there. Now this one's kind of cool. Can you see what's going to happen already?
It's the same thing as like. Wait.
It's going to go. Wow.
Isn't it just like it's just like sine, right?
No.
Wait, then what's the?
It looks more like the
Wait,
third root of x.
Wait, can you come explain something to me?
It looks more like the third root of x.
Can you come explain something?
Mhm.
So, like when it says restricted domain like this, and then this one, what are those? Like, why isn't this the same as that?
Because they all look different. So if you think about okay, here's the cosine one. Okay, I can't. It's got to become 1 to 1 at some point, right? If I picked negative half to half, it wouldn't work, right? See how those two y's repeat?
Wait, what'd you say?
Could I pass the horizontal line test if I picked that green piece? Yeah. The horizontal line test tells me if it's 1 to 1. I have to pass vertical line and horizontal line. This one doesn't pass the horizontal line, does it? Therefore, it's not 1 to 1. So I have to find a segment on this that would be considered 1 to 1. And that segment goes from here to here.
Which means that every x has a y.
And every y has what?
Wait, so it's not like. I thought
So the
y's
invert-
can have more than one x though.
Well, there's two types of functions for starters. No, you're not. Listen to me. A function, in order just to be a function, just like, hey, I'm a function, I'm a generic function. The only rule that I need to pass is every x can have one y. Okay? Not all these that are functions will have an inverse. Okay? In order to guarantee that it does have an inverse, it has to be a special type of function we call 1 to 1. Which means every x has one y, and that y is also attached to just that one x. Like a monogamous relationship. Okay? So, if I look at sine by itself, it's not 1 to 1. It's a function, because it passes the vertical line test, but it's not 1 to 1 because it doesn't pass the horizontal line test. Okay? So in order to do this one, what we'll have to do is restrict the domain on it. Okay? We'll have to restrict the domain, and we'll do it from this piece to this piece, because if we only look at that piece by itself, then it does become 1 to 1, doesn't it? What?
So when you're restricting, that means you're making it.
Then we can find an inverse. We did the same thing with quadratics, remember? You remember we did the same thing with quadratics? A parabola is a function, right? Oops. So quadratics are parabolas, but is it a 1 to 1 function? No. No. So what we did is we restricted the domain from 0 to positive infinity. We restricted its domain from here to here, and to find its inverse, turned out that it was y equals the square root of x, right?
Yeah.
and it did this piece. Oh, look. Okay, don't look. But there's its reciprocal. We've done this already with parabolas. We're just applying the same thing to our trig functions. Parabolas, I love them. So all we really look at is this blue part, and then what we'll do is we'll take a look at, there's the inverse of it, okay? Because we're only looking at one piece of it, and then it's going to turn into a little swimmer. What part? No, they don't. Not always.
Tangent domain is, like in the parentheses, it's negative pi over 2 to pi over 2, but in sine, it's like negative pi over 2, and then x is pi over negative and positive. I just don't get the positive why they you know what I'm saying? They're using the same point. Why are they not saying?
Can I change this real quick? You guys good? You still writing something now? Anybody still writing something now? Okay. Okay. This would be. We're okay there? Okay.
Sine, right?
Yeah, good. Good. So, which piece do I need so that it has an inverse? Where would I kind of cut it here?
Pi over 2 at the top and then the pi.
From here?
Yeah, that point all the way down to the. No. Other way.
Go the other way? Okay. So I can go from here to there? Good. So what's the domain here? Just this blue piece.
Negative pi over 2, and then pi over 2. It goes to.
Right? And then the range is
Negative 1 to 1.
-1 to 1. Does this make sense so far?
Y is equal
Well, what's my amplitude? How far up does it go? 1. How low does it go? -1. Okay? Because we always go from smallest to biggest. We read left to right, up, down to top. Okay? So you're okay with this? Now you're saying y isn't the same as tangent?
It's like the domain on the slide. It's
Okay, so you're okay that the height here is -1 and the minimum is -1? Okay, so let's do this. Let's look at tangent. Okay? Here, this is pi halves, there's an asymptote, correct? Here at negative pi halves is my other asymptote, correct? That's when the denominator becomes 0, and it just doesn't touch that. Right, okay? So then the graph will look like this. And then that repeats itself, right? Over here would just kind of do this bit, over here would do this bit. But technically it's just repeating that same pattern. Okay? Now, if I wanted to just find one piece of it that was 1 to 1, where would I go? It would be this piece right here, huh?
Yeah.
So I would go from, my domain, I would go from, parentheses. Not equal to, because I'm not actually that, right? See how it's a bracket here? Because I can actually be that value. Is there any asymptotes in this? No, so I can actually be those values. Over here, can I actually be negative pi halves? No, because there's an asymptote there, right? Parentheses. Now, I'm choosing to go from negative pi halves all the way to pi halves, parentheses, correct? Okay, let's look at the range now. How high does it go? Forever. Yeah, these go on forever. So negative infinity to positive infinity. And that's why they're different. This actually stops at 1 and at negative 1. While this one does not. This one goes up forever. We might be looking at the same interval for the one-to-oneness, but the ranges look very different, don't they? That's why they're different.
So sine denominator, sine denominator is bracket.
Yes.
No parentheses bracket.
No. Parentheses would be on the tangent.
What is the, so right, negative, could you go to the next?
New slide?
Yeah, so negative, right, negative pi over 2, and then, like, bigger than equal sign kind of, but like, or less than equal sign. Yeah, and then x, and then another one, and then pi over 2, and then, right, go on the other side, right, in parentheses, negative pi over 2, and then comma, and then pi over 2. So like, it says like, y equals, so like,
Parentheses or bracket?
those are parentheses. So that one right there, the right one.
This one has equal to?
Yeah. So like it's that left one right there. It says y equals sine of x has an image function. And then the other one says the tangent. What are those?
Same thing. Same thing. This, here, it's two different notations. Okay? So if I wanted to write this in that notation, I would go bracket, negative pi half, comma, pi half, close bracket. Remember I said in the sign it's equal to? Tangent is not. If I want to write this in that notation, I would go negative pi halves
Less than
x less than pi halves. It's just different notation.
So basically,
That's not the domain.
Yes, they are.
Wait, but I thought.
Look here. What's the domain on my sign function? From where to where? There's my domain. Look at the tangent. It's still from negative pi halves to pi halves, but I can't be the endpoints. That's why parentheses. See, like here, is there an asymptote there? No, I can be that value. Over here, I cannot. I can get closer, 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 but I will never be that value. That's why parentheses. It really depends on you, and MATLAB will prompt you. It might because it might say use interval notation, or write an inequality. And that's why I said you're gonna have to write these down and just kind of understand what they are, memorize them. There's your values, guys, for tan. Did we already do this slide?
No.
Okay. Because you always want to be as close as you can. Right? Because that makes it easier. You could have, that would make everything okay. You would always have to transfer to pi halves. Does that make sense?
Actually, there was a lot of I know, right? I told her that too.
When you graphing them, can you see how it's easier to flip something over y equals x line? I mean, you could do something like that, but it would be weird.
Yeah, we'll put next super different.
What's the last part to it? Because I haven't done a question.
What was the last part? Well, there's the
Those are the inverses.
We did that? What's this? Oh, it's all three of them. It's all three of them, right? This one is the sine. This one is the, yeah, the cosine. And this one's the cotangent. It's just all three of them side by side. You should already have them, so there's no point to do them again. I can change the slide?
Yeah.
Raina, you good? Because technically we already did them.
I just have another question. I don't want to like take them one at a time.
Okay. Calculator time. Oh. I'm going to show you how to do some of these on your calculator. Calculator. Okay. So if I want to find cosine inverse 1/3. Now can you guys do that one already? 1/3. Oh no, that one's harder. Oh, that would not be fun. Never mind. I'm going to go to my calculator. And right above sine, cosine, tangent are your inverse values. So we wanted cosine, right?
Yeah.
So there's cosine inverse. 1, divide, 3, close, and there it is. But, what am I looking at right now?
Radiant.
No. This is the degrees, because I'm in degrees, so this is angle in degrees. If I wanted it in radians, I go mode, go over to radian. And you should probably do radian. Second, quit. I'm just going to go enter again. And I get my radian value, 1.23, which is, I believe is what they were looking for. There it is, 1.23. Okay? And your tangent and so your sine, your cosine, and your tangent inverse are all there. What if you need to do secant inverse?
Wouldn't you just do
Yeah, 1 divided by. Correct. So if you want to do cosecant inverse, you'll have to do 1 over sine inverse. Secant inverse, you'll have to do 1 over cosine inverse.
Those are trying to do the cosecant and the secant.
Right, and then for tan inverse, you'll have to do,
1 over 10.
sorry,
Cotangent.
cotangent inverse, you'd have to do 1 over tan inverse. Okay? So make sure you know those things as well. Yeah?
So like let's say we want to find the secant, it would be 1 over like,
Cosine inverse.
so it would be 1 over 1/3 or 1 over 1 like,
It would be exactly that, but you would just divide it by 1. You would go 1 divided by that, sorry, not 1 divided.
divided by the number that it's giving us, not the number.
So if I wanted to find secant inverse, I don't know, 2/5. Okay? I would go 1 divided by, and I like to do this. Oh, wrong one. Cosine inverse. Oops. 2 divide 5 close, and there is secant. Okay? I did use cosine, but because I did the reciprocal, it should give me the secant value. Okay? We're good? There's all 3 of them side by side. Anybody need this? Take a picture.
So you know how earlier you did the sine and then 30 degrees?
The sine 30 degrees?
Yeah. How do you do that to like interval of like how do you find like the domain so like something like that or something like that? Like
They won't ask you for a domain of sine 30 degrees.
it's like how do you convert like one of those into like finding
You don't. The only thing you would find an interval for is like a sine function or a cosine function. But if you're doing like sine 30, all that's asking for is the ratio of the opposite over the hypotenuse side. So what I'm saying is, if they did that, actually they don't even need this equal. You can't get a domain out of that. I mean, I don't see them asking you a domain right now, so I don't see you worrying about that. What I would just do is figure out, oh, there's 30 degrees, 1, 2, square, 1, 2, radical 3. The sine is opposite of our hypotenuse, so it's 1/2. Well, the cosine of this is not an interval, it's an exact point. Remember, it's right here, correct? The x value would be radical 3, the sine value would be 1. So kind of close, if they ask you for the domain, it would be the x value, which is negative, it's radical 3, sorry. And if they said range, well the range is 1, right? So it's not going to be an interval. They'll ask for an interval. They'll ask you.
How do you know whether like to like less than or greater than something? Like how do you know where to put first one and stuff like that? And like whether it's I know like the brackets means like the greater than or less than, but like how do you know where like it goes in your position?
Look at all the x values that this function has. Okay? Where does x go from? What values of x can I actually have? Do I have x values over here? No. Do I have x values here? Yeah, here, don't I? I have x values here? Here, 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 here. How about there? So my domain is from -2. So x has to be bigger than -2 or equal to it, but less than or equal to the +2.
And then if you were to do like let's say it's in non-interval notation and that's a sine function.
No, that's crap.
So
I just put something up there.
in that case, how do you know it's bracketed? How do you know?
See how it's closed circle? That means equal to, doesn't it? Brackets. Now, if I, for some reason, made this one an open circle, then over here it would be open, and over here it would do that. Okay? No, that's it. Let me turn this off real quick. It's getting way too loud in here.